Welcome back. In this video we will learn how to algebraically solve inequalities. The main point is that we can treat them mostly like equalities. This is good when the questions are more complicated. So first we need to understand what happens at our inequality points. So if we take our previous example of x squared is less than x and redraw our graph. So we have the x squared graph and the y equals x graph. Our critical values are at 0 and at 1. So we can see that when x is in this region, so x is less than 0, the graph of x squared is greater than the graph of x. When x is between 0 and 1, the graph of x squared is less than the graph of x. And when x is greater than 1, the graph of x squared is again greater than the graph of x. So the one that satisfies our inequality is this region here, which we saw in our previous example was correct. This is mirrored through all examples. If a graph passes through a critical point, the sign will swap. So another example, if we solve x cubed is greater than 4x. Now remember, we can't just divide by x because we don't know if x is positive or negative. So we would need to change the sign if it's negative. In these cases, the best thing to do is to bring it all to one side. So if you minus 4x off both sides, we've got x cubed minus 4x is greater than 0. Now we treat this like an equality and solve for x. So x cubed minus 4x equals 0. If we bring an x out to the outside, we get x squared minus 4. And then this is the difference of two squares. So that becomes x plus 2, x minus 2. That's a neat trick you do need to know. And now x equals 0, x plus 2 equals 0, x minus 2 equals 0. So now x equals 0, x equals minus 2, and x equals 2 are our critical values. Now if we put these values, if we put numbers that are between these values into our equations, and we will see which is larger. So we have our two equations. So the question was x cubed greater than 4x. So our two equations are x cubed and y equals 4x. So when in the region where x is greater than minus 2, so for example x equals minus 3, so y equals x cubed will give us minus 27, y equals 4x will give us minus 27, sorry. So then we get x cubed is less than 4x. In the region where x is between minus 2 and 0, for example x equals minus 1, the x cubed equation will give us minus 1, 4x will give us minus 4. So here x cubed is greater than 4x. In the region where x is between 0 and positive 2, so for example x equals positive 1, the graph of x cubed will give us 1, graph of 4x will give us 4. So in this case x cubed is less than 4x. As we can see, the signs are swapping each time. So as we can expect, when x is greater than 2, for example x is 3, x cubed will give us 27, therefore x will give us 12. So x cubed is greater than 4x. So we need greater than. So here and here solve it. So this set and this set solve it. So in summary, the regions that satisfy our equation are minus 2 to 0 and x is greater than 2. This is our solution set. On a number line, we can illustrate this. So empty dots because it's strictly not including the values. There we go. So our next video will show you a particularly hard example to do with asymptotes.